It's you.
I'm remembering tonight. I'm ready. Let's do this. Oh, geez, I forgot I had a ponytail in. Hang on. There we go. Oh, whew. Yeah, anything y'all need to look at?
Well, I wasn't here Monday because I was in the hospital. Was the video posted?
No, it was not. I have, that's going to happen tonight after class.
Okay. Okay. I just have to pretty much go over that to see what we went over.
I got to remember what we even did. I forget. This morning's class said they covered like half of 4.2. Is that about where you all are at?
Mhm.
Okay.
I think so.
Yeah.
So, well, while you're all are getting up the courage to ask a bunch of worksheet questions, let's do a quick overview of 1.2 and chapter 4, because 4.1, 4.2, and 4.3, they're all just like the same thing, essentially. They're not, it kind of builds into one big piece. So 1.2, there are two concepts you need. Did we talk about this? Why am I thinking we did this already? Did we do this? Have we talked about an observational study? No, that was my other two classes, surely.
Talk about it with Cindy.
Okay, so you all basically know observational study is just Mary, that we're like on page something. I'm just doing like a reference sheet overview of the main things you need from the notes you did, starting with the 1-2 section that you did with Cindy probably last night. And then we'll look at some worksheet stuff. So there's two types of studies. One's the observational, one's the design. The observational study is simply analyzing a data set that already exists. I think is maybe a nice way to talk about it, look at it. So examples of this is like, what if we wanted to determine the effects of smoking cigarettes while pregnant? You can't design that study. Like a design study would take, say, 100 pregnant people. Half of them say you smoke 5 packs of cigarettes a day. The other half you smoke nothing, and let's see what happens at birth. Can't do that. Super unethical. We kind of know cigarette smoke is not particularly healthy and for us, anyone, and probably also for the fetus and the unborn child. So what we do is we go to a hospital and contact all the women or all the people that gave birth at some point and say, how much cigarettes did you smoke? You find the group that smoked a bunch, you find the group that didn't smoke while pregnant, and you compare the outcomes. That would be an observational study. The key point of this observational study is that any comparison between two variables, we can only claim correlation. We can only say we see a connection here. We can't say that, say, the cigarette smoke or smoking cigarettes caused this or that. Too many lurking variables. Whereas with a design study, we can claim causation because we controlled for all the lurking variables. So maybe the idea here with the design study is the researchers control everything. It's kind of an overview. Researchers control everything. It's costly. Obviously, there's ethics things involved. There's all kinds of stuff that goes in with the design study that sometimes are just straight impossible. One of the ones that comes to mind here is when beauty products or any kind of personal care, shampoo, any of that products, you get a bunch of people to volunteer to test it and see if there's any reactions. Maybe even a bigger one was the COVID vaccine back, 3 years ago. Thousands of people volunteered to be the first ones to get the shot, to study the effects of it, the effectiveness and all that. Those were all design studies. Okay, so from that, we get that there are two types of variables in these observational design studies. For this course, we are only going to be looking at studies where we compare two variables. You can compare multiple variables at a time. So we're looking at a really pared down basic thing. The two types of variables are the explanatory variable. And I think the simplest definition of this is the X variable in terms of how we graph things and how they show up in tables. And then the response variable is the Y. So what we're claiming here is, no worries, Alexa, is that when that the explanatory variable is creating some sort of change in the response variable. If we designed the study, then we can claim that the explanatory variable caused the change, if we were careful in how we designed it and our analysis is good. If it was an observational study, we can say there's a correlation between the explanatory variable and the response variable. This is a weaker claim. I believe coffee has been correlated with cancer and reduced heart disease or something. Like, there's all kinds of correlations between drinking coffee. I don't know that we have much causation of stuff yet. Here's how things show up graphically. If we hand you a graph, the x-axis, whatever that's defined as, that's the explanatory variable. The y-axis, whatever that's defined as, that's the response variable. And then if we give you a table, x is always the first column, y is always the second column. If we give you a table horizontally set up, x is always the top, y is always the bottom. And what's happening here is we are pairing these two variables together as an XY ordered pair. So explanatory, response. And then we graph all these things, all these x comma y's, and we see, is there some sort of relationship, correlation? Like, do they seem to form a line? That looks linear. That looks like a positive linear correlation. Which leads us to chapter 4. We are only looking at one type of correlation, and that is a linear model. So a linear relationship. We can call it the linear model. It's the regression model. There's all kinds of different names for this. And it has bunches of different flavors. We get the y hat equals b plus ax is how StatCrunch will write this. And this morning's class said Cindy did a great job explaining these things.
Just
talk to me.
Yeah, you guys correct me if I'm wrong, but isn't it in the notes that it was y ax plus b?
100%, it's in the notes that way.
Okay,
Yes.
so does it not matter?
Same thing.
Okay.
It's the question, the answer to why it's the same thing is, what's the difference between 2 plus 3 and 3 plus 2? Which number came first is the difference, but the result is the same, right? So the order we add things doesn't matter.
Okay.
And I did this on purpose. I wrote it this way because StatCrunch always writes it this way.
Oh, okay.
The output, it's the y-intercept first and then ax. And a common mistake I see students make is they look at the first number and call that the slope because that was the first number in the notes. But the slope is the number times the letter x. So good, really good question, good points, good things to keep track of. There are a couple things that go with this. There's the R which is the correlation coefficient. And then I know you didn't get this far, but I'm going to write it here anyways. There's R squared, which is the coefficient of determination. And you will see that in the notes tomorrow.
Eric, we didn't quite get to R squared yet. We did R, but not R squared. So we didn't do 4.3.
Yeah,
But
we
you
did.
can go over it with them.
I'll just toss it on here. Yeah.
Yeah,
We-
toss it out there.
We this morning we
They
didn't cover it.
know where the number line is, right on page 263.
Yes, that's where we're going next. And then the other thing I know you all didn't cover is the residual. I'm just going to toss it on here. You're going to learn about that tomorrow night. And that is y hat minus y. Another way to think of that is the model value minus the data value. Okay, so that's it for chapter 4, really. And what we did this morning, which I think worked okay, is we started with project 2, which gets us jumping right into StatCrunch and looking at all the printouts and graphs and things. So I think let's start there, unless someone's got the courage to ask some worksheet questions yet. Usually that comes later in class. Well, let's do it then. Oh boy, the emails are stacking up. I made the decision to delete chapter 4, project 1. Did I do it in this class already? I did. So go to day 7. And we're going to look at chapter 4, project 2. So y'all remember the drill. You open the link and then you download the file.
We can cross the chapter 4, project 1 off of our list then.
Yes, I deleted it already from Canvas, it looks like.
Thank you.
You are welcome. I figured not too many people would be upset at me for that. I mean,
I have
it
a
is kind
question
of-
about last week's projects.
Yes,
Chapter 3, project 2 was to be deleted, right? Because mine says it's missing.
I swear it's deleted. You know what? I bet it's deleted from the modules and not somewhere else. I haven't been able to find it in the list of the modules. Chapter 3, project 1, chapter 3, project 3. So it's not there.
Yeah, mine says missing too.
Where does it say? It says in the grade book.
Yeah.
Okay, well, we're learning things. So deleting it from the modules doesn't delete it from your assignment list. That's fun. And I know students hate missing things. Did anyone enjoy all of the worksheets I graded? Oh, you even got a notification. Good gracious. Okay, I'm going to have to figure out how to make it actually disappear from your list of things. Maybe there's maybe if I go to assignments.
Did you do grades last night or today?
I didn't do them at all. It was a really bad joke.
Ah, okay.
I just went there to look. I was so excited.
I know, I was too. I was like, okay, all right.
He graded something at long last. Oh, no. Oh, here it is. Gone. Go away. There are submissions. Oh, that's why some people submitted it.
So you're just gonna give everybody 100% then, right?
Yeah, a 0 out of 0, 100%.
Oh, dang. I tried, everybody, I tried.
Oh, man. Thanks, Will. I'll be honest, you all, I am struggling this semester big time, and I have got, you are not alone. Of my 6 classes I'm teaching, I have graded a total of 3 assignments out of all 6. And my 3 stats classes have turned in 13 assignments that need to be graded. And then my 2 130 classes have turned in 6 assignments. So I'm a bit behind. So if any of you feel like you're behind, you're not. You're like way ahead of the game compared to me. Hey, it got deleted here. Okay. All right. Okay. So There, I think it's gone now. If it's not, keep telling me it's not until I figure it out how to fix it. People kept emailing me about it. I'm like, it's not there. Stop telling me it's there. It's not there. Ugh. Okay, so we're getting to StatCrunch, and we are going to do this project as a starter. We're going to have to search for this because no one filled out the survey about their arm length because I didn't actually assign it to you to do. And the good news is there's a data set in here from one of my colleagues who is more on top of things than I am. So if you search for under data sets arm length, the one we used this morning was the Shepherd arm length. You can pick any one of these arm length ones you want. There's an old one of mine. It's not a very good one. There's some weird numbers in it. So just grab this one. And I will pause and you all let me know when you've got everything ready. I'll show you here's where I searched for it, and there's where I got the arm length. And then don't forget to open up your project. And if you want, you might just be able to do it. I don't know. You might not, y'all might not need any help. Other than some of the later stuff that you haven't covered the notes on. We're probably going to do like half of this.
Shepherd arm length versus height, is that what we're,
That's the one. That's it.
and we have.
Should be the very first one because it has the most views.
Data sets. Arm length. Oh, okay.
Okay. I'm going to start showing some things. The first thing you were asked to do is make a scatter plot. Well, actually, it says scatter diagram, right? But remember, that's the same thing as a scatter plot. And to do that, it's a graph. You go to graph and select, surprise, scatter plot. Now, remember that our X variable is always the first one in our data set, although we could have typed it wrong. But we're going to let the forearm length be the explanatory variable and the height be the response variable. So if you pause and think about what we're claiming, we're more or less claiming that we could measure someone's forearm and predict their height. That there's some sort of correlation between the length of a person's forearm and how tall they are. That's what we're testing here. There's tons of options you can mess with the scatter plot. You don't need to do any of that. Just compute it. And there's your graph. And if you recall, the way we talked about copying it was going to options, copy. So it creates this new image. Right click it, copy image. Go over here, right click and paste. And there you have it. Now mine doesn't fit in the view screen, so I gotta make it a little smaller. Too fast? Too slow? We all good?
Good.
I'll show you the one other output you have to create in StatCrunch. You might all already know it, but the other one is for question 3, and then you just need to interpret all the information you've gotten. And that is the simple linear regression results. So you click graph and scatter plot. And then you define which is the X variable, which is the forearm, which is the Y variable, that's the height, and then compute, and you got a graph. So the regression stuff is under the stat column, or the stat menu. And there's a regression tab or menu, I guess. And we are only ever going to do simple linear. Multilinear is when you have multiple variables and you believe there's a linear correlation. Awesome, Alexa, good. So same thing, same options. We have to define the X variable and the Y variable. And there's all kinds of other things in here that we're not going to do. When you click compute, don't be overwhelmed by everything you see here. The stuff we need is just this top part. Well, that other stuff I did in grad school. So what, if you notice what I did, I left clicked and held and dragged my mouse across the screen to select this. I'm then going to copy it by right clicking and come over here, right click and paste. And there's all my stuff. It's kind of small font by default, so you can make it larger if you want to make it easier to read things, which seems nice for me. One other thing, there's a second graph. This graph that you're being asked to paste here is buried in this menu. So when you did your simple linear regression, down on the bottom right corner, there's these little arrows. If you click it, you get the other graph, that another scatter plot that has that line graphed on it. And if you put your mouse on top of the line, you can see the equation for that line. And like I said in the notes earlier, that's y equals b plus a times x. That's just how StatCrunch is programmed to report.
So what do we want to call that line? Because they don't like how it's line of best fit, regression line. They don't like that it was 5 different names. So what do we want to call? What do we want to call this thing?
Yeah, what'd you all decide?
No, we said whatever you were going to say. We were going to go with it. No, they
Well,
liked what?
No,
What did you?
we thought,
I don't think we decided.
I thought we said regression line or. didn't we say
Regression line.
that? Did we not? Maybe I'm thinking of something.
Not linear.
Let's
Not
call
linear.
it.
Oh, that
this-
was for something else that we decided
Oh,
not
Okay,
linear.
okay.
Then it was there was
Okay.
something else that had multiple things, no correlation, that thing, and they're like, can we just say not linear? And I'm like, yeah. So you guys want to call this I think line of best fit works. What do they call it?
Let's call it the
Nothing.
simple linear regression line of best fit that is also
Oh,
spoken
what the heck?
separately. No?
Oh, yeah, this is supposed to be easy.
Here's the problem. We can call it whatever we want, but look at
They call it simple linear regression.
here it's called simple linear regression. Let's see. Let's find some other spots in the worksheets.
Yeah, they're gonna call it. They might call it line of best fit too.
It might be,
Can you
yeah.
repeat the steps for that graph?
Yes, here it's called the least squares regression equation. Here it's called the linear regression model. Here it's just called the
Sorry,
model.
I guess
Here
we
it's
gotta
least
know.
squares regression model,
What the hell
Regression
is that?
line.
regression line. So you
Whoever
kinda
came
have
up
to
with
know
this
all of it.
stuff wanted people to fail math. They did
Well-
not want people to be successful.
What do you call pop?
Pop.
Soda, Pepsi, cola?
It is soda.
It's
I
pop.
call it yummy if it has rum in it.
Yeah. Someone wanted to see the graph again. Let me show that. So the second graph we got from the simple linear. Isn't it the Eskimo language that has like 20 different words for snow? We're just like, it's snow, and then they got all the different ones. The graph is, see how it says 1 of 2? That's telling you there's 2 pages on this. And down in the right corner, there's the arrow. You click that, and there's your second graph.
And the first one was just a scattered graph. What was it called again?
Right, which is it's here, it's called a scatter plot. The project called it a scatter diagram. And this scatter plot is the exact same one, but it has a slightly different scale. Well, I guess it
Scatter
doesn't.
plot. Okay, so the first one was scatter plot and the second one was the regression linear thingy. Okay.
And notice there, Alexa, did you get this? Did you get here?
I haven't got there yet.
So look in the bottom corner, and then I don't know who said you hadn't gotten there yet, and I'll come back to you. Look in the bottom right corner and click this darkened in arrow, and you'll see the second graph.
Mary, you look distraught.
She's trying to,
Who else said they hadn't gotten there? I can do it way slower. I know I'm,
I haven't gotten there. I got my scatter plot part.
so
I lost you.
the second spot is go to stat. That's where this thing is coming from that's on the screen right now, this mess. You go to stat and then regression and simple linear. We all need, the ideal setup for this kind of learning would be to have a computer with two screens. One, where you could have the full screen of Zoom and the other, the full screen of your StatCrunch, but you know, not all of us, I don't have that. Not all of us are hardcore gamers.
I got there. Thank you.
You good? Okay, excellent. Oh, Mary. Coke and rum is good for that too, isn't it? No, I don't know. Oh, yeah, that's no good. Okay, so did everyone get the two outputs you needed to generate from StatCrunch? You know how to do that now. So what I would like to let you do is take 10 minutes and see how much of this can you do without any more assistance. And the assistance you should really be using before you ask the rest of us anything is the page 263 of your notes, this mess. This should get you basically everything you need. Now, some of it you don't know about yet. Oh, come on. You don't know about the formal interpretation of R squared, and you don't know about a residual yet. So if you can try those things, but if you don't get that far, don't worry. Does that sound good? Set a timer for 10 minutes.
I'm sorry, what are we doing?
You are doing this project as much as you can. And of course, if you get stuck,
Okay,
ask questions. So we put together the outputs. So the scatter plot with no line, then the regression stuff with the scatter
That
plot
one-
with line.
the regression, I had to step away. How did we do that?
This thing right here, right?
Yeah,
Okay, so you go to stat,
yep,
regression,
stat, regression,
and then simple linear.
oh, and then simple linear, okay. And then we do the same thing for the X variable and the Y variable, the
Yes,
forearm length for X and the height for Y.
good, good.
Oops. Okay,
And then you get a bunch of extra stuff.
uh-huh,
So you just click and drag select that top part.
okay, so compute, right?
Oh, yep, compute.
Okay, okay, so it's just, I stop at the perimeter estimate, or I put that in there too?
Yeah, you don't need that. That's way beyond the
Okay.
scope of this class. Yeah, definitely.
Okay, so it's just the top,
Correct.
and then,
So Alexa, that formula is kind of hidden there. See where it says height equals, yeah.
So if you go to the graph, StatCrunch takes away the names and it turns it into the letters.
Yeah, it's
And
nice.
the other thing you could do, which might be nice, might not, you could relabel your table to be X and Y. And then when you compute it, look at what it does for the equation as the output. Now it's written it the same way it did in the graph output. The downside of that, of course, is when you do the interpretation of the slope and the y-intercept, you need to remember what X and Y stood for. X was forearm length, Y was height. But that will at least take away the word mess when it gives you the equation.
So are we copying this page or the second page for the project?
Both. You need
Both
this.
on the same question.
Yes, because here it says paste in the simple linear regression results, and here it says paste the graph that has the line in it.
now, how do I do the graph?
You just click the over button. This little page button
Oh,
down at the bottom.
okay. Oh, okay, and then just copy the whole thing,
You got it. You got it.
okay.
Other questions y'all have? Or are you all making it?
I don't know how to figure any of it out. I'm completely lost. I'm just gonna put it out there.
I'm with
Awesome.
you.
Thank you, Misty. I would guess that at least 50% of the class feels the same way as you. It's funny because I always think that, but then I'm just like, well, let's let them struggle for a while.
I think we
So-
struggled long
Struggle
enough.
silently.
Everyone's like, no, don't struggle in silence. You are not alone. I think that goes for lots of things in life. Okay, so let's go through it then.
Yes.
So the first question where we have to make an answer is we're to look at this graph and say, all right, what type of linear relationship is it? Now, remember, when we're talking about a relationship or a correlation, there are two things we're stating. We are stating the strength. So that's strong, moderate, weak, or no correlation. And we're stating the direction. And that is positive or negative. So when you look at this, what do you think?
It's positive.
I
Bunch
said
of
big
dots.
positive.
Positive, and then what about the strength? I agree, positive. Let's do a line like that.
I said
Okay,
weak.
perfect. All of those answers are perfect. It is difficult to look at a graph and be able to correctly state the strength because it's subjective. Like, how close are all these dots to a particular line? Like, it's probably easier to state the strength looking at this graph because the line of best fit or the model of best fit is in there. And you can see, oh, there's some points here that are kind of far away. Come on now, kind of far away from the line, and some up here, but then a lot of them are really close to the line. So whatever you said here is fine. Your explanation, oh, the points are close to the line, or the points are kind of spread out. Good. Then we get to, all right, you've got to actually know what you're talking about because here's all the output. And the first thing we do is to state the linear correlation coefficient. Do y'all know what that is?
0.509.
You got it. Note StatCrunch states it as capital R and then parentheses correlation coefficient. So StatCrunch is kind on the R value because it states both right next to each other. So we just need the point, we needed 3 decimal places, right? So 0.509. Awesome. Now, does this support or contradict the strength and direction? Well, before you answer, read this and then answer.
For me, it
Okay.
contradicts.
Okay, because you said something.
Weak.
You said
Weak
weak.
positive. Yeah.
Well, if you look, you're not too far off. Our R value is 0.509,
Yeah.
and the threshold of moderate is 0.5. Like, that's where it begins. So we're close, right? And that's why it's part of it. This is a rule of thumb. It's like, this is just what we typically do. And how could we have gotten it right by looking at that graph? Like, it's really difficult. So that's why we have this R value.
Okay.
Cool, good. How's everyone doing so far? Anyone? Moderate, anyone lost?
Yes, I am so lost.
Talk to me.
So again, on number 6, you guys, the coefficient of determination, you're gonna look for R squared, or just look where it says coefficient of determination. We didn't get to that last night. And Eric, do you mind if I talk for just a second?
Go, talk away.
Because there has been a change about tomorrow. I'm now not headed to Boston, but I head directly to Maine because my son in Boston test is his lab, research lab, has tested positive for COVID. They went on a retreat last weekend and 9 people, and he's tested negative, but feeling the symptoms. So he is he is not coming right now. So I'm not going to be doing my 11 to 1 class, which I need to send out a thing because we are going to be in the car. We're on our way driving straight through like 19 hours, 18 hours straight through. But I will be able to do this at night section tomorrow night to do the notes. So if any of you will agree to be there with me so that I can record notes, I don't want to record myself. Would any of you be willing to be there tomorrow night to listen to the 6 to 8 notes?
Oh, yeah.
Yes, I would.
Yeah,
All right. So I will send out an email to the day class. Well, everybody. I'll send a reminder as an email as well that said we will not be doing the 11 to 1. They can listen to the recording. So you guys are the lucky ones now that actually get to see the recording, or not see the recording. You get to see the in live person because I will be to Maine before 6.
Okay.
Sorry. I hate to interrupt all your project fun, but I wanted to get that out there. I'm in the car now and I'm really trying to figure out how could I get my DocCam and everything to work that I could that I can do it from 11 to 1, but I'm just thinking there is no way this is gonna work. So and my daughter's like, we could stop for 2 hours, Mom, and I'm like, no, I just want to get there. So you guys will be the good one. I'm gonna like record the night section, post that so the other class can watch your section. Which I'm not going to say that I like you guys better. I'm not going to say that.
They might watch it, the morning ones.
I'm not saying that.
You like everyone equally best.
Equally best. That's right. Okay, back to project.
Good, good. I don't know what state crunch is here. So some of this we don't know yet, so don't sweat that you don't know it. If you want to know the coefficient determination, StatCrunch calls it R-SQ for R squared. And that is this number right here.
Is that how we should write it if we have to write it out?
Well, you're also going to see it look like sometimes it's not capitalized, so sometimes you'll
Yeah.
see this.
So
Oops, too many.
What's your preference?
I don't care. As long as you know R squared and coefficient determination are the same thing. Mostly how it shows up is it says write the number. Like I remember on the midterm I graded, it just says write the number for R squared. So you don't even need to write it because it's in the question. Now, if you want to interpret this, that's where you jump back to here and you just write this. Blank percent of the total variation in height is explained by the model. I take out all this stuff and just say model because it's less to write. But if you like that least squares regression line, by all means, type that in there. Now we have to do one thing, a common mistake. Note this is a percent. R squared is given to you as a decimal. So if you're going to write the word percent, which you should write this as, what did it say? Give 3 decimal places. So we should be writing this. You would say 25.9% of the variation, however you spell that, in height is explained by the model. So again, you're gonna talk about this in your notes a little more. You're getting a bit of a preview of that. How we doing? Anyone have a question?
Oh.
I suspect for many of you, this is something you've never seen before because this is a not a common thing. You've maybe seen the y equals mx plus b stuff, but correlation coefficients, all the else, that's a very unique thing to StatCrunch. Yeah, so let's get past 7. All right, so state the equation of the least squares regression line. That is this. And that's where if you replace the letters, so this should really be y hat. I'm just going to leave it. So that's y, and this is x. If you replace the words with the letters x and y, then it's maybe a little more obvious what you have here, that that's the equation. But StatCrunch will do that. Every time you run StatCrunch, it's going to take whatever the column things are, whatever the labels are, and it's going to write those in for the equation. So here I had replaced x and y, and now it's x and y in here. Which means if you put in a bunch of data and you leave it as var1 and var2, you're going to see var1 and var2 in the output. So I'm just doing Control-C and Control-V. Now it says 3 decimal places, so shoot, I'm gonna get rid of all those. And shoot, get rid of those. And there's your equation. Now, if you don't like the order, because this is the different order than what the textbook did, just move it around. There's the same order of how it's written in the textbook. Y equals mx plus b. That sounds like a sigh of excitement. I love it.
Oh, God.
Now, well, how we're doing? Anyone have a question?
And where is that in the book? And the where it's
This, well, let's see. So the reference sheet stuff is here on page 263.
oh, but where is it?
But in terms of that linear equation stuff you're just talking about, that's 4.2. Man, Cindy's blowing up my phone. So where you encountered that in your
Sorry,
notes-
Eric.
No, you're good. You're good. Would have been right here, page 118.
Okay. Oh, yeah, okay.
Get double because you're on both classes, that's
Oh,
why.
that's right. That's right.
And wait, because I'm gonna send one more, so you're gonna get
Nah,
a
you
ding ding.
blow it up. It's cool. I should have my phone upside down so I don't even see messages coming through. Although in my in-person class, people got really chatty, so I just started sending text messages, and then I said, well, I'm done texting. Are you guys ready to listen? And they got quiet.
And I bet you they're not talking about math, right?
Oh, of course not. I said something crazy, I think, and so that got everyone in an uproar. So you are going to use this to interpret that thing, and see how it says X. Our X is arm length. And our Y is height. So let's see, where were we?
So X.
So first we should, does everyone know what the number is for the slope? A equals what?
One 1.252.
Nailed it. Slope is always the number times X. Now, the thing to keep track of is this is really a number over 1. And the top number is the Y variable. So this is 1.25 centimeters, oops, easy there, centimeters of height. And the bottom number, which is always a 1, because StatCrunch always gives you slope as not a fraction. So we know it's always a 1. That's centimeters. Easy. That would be centimeters of arm length. So now when we interpret, if you keep track of those units, you're ready to go. And we start with that sentence structure. On average. On average.
How did you get that in there?
Oh, how I did that?
Yeah.
Trickery. If you hit Alt equal, it allows you, it opens up the equation editor. And then I typed in the number. Oh, well, I turned off my number lock. I typed in the 1.252 and then the division sign and the 1, and I hit space. And what it does is it turns it into a nice fraction.
Okay. All right.
You could also do, but don't feel like you need to do that.
Okay.
I'm just writing that to help you all understand. Hopefully it helps you understand. Okay, so on average, it said if X increases by 1 unit. So if arm length increases, or maybe we should say, maybe we should just look at what it says. If X increases by 1 unit, that's exactly what it says. If arm length increases by 1 centimeter, comma, Y, which is this arm, or the height is expected to, and here we have to decide, is the slope positive or negative?
Increase.
Good, we say increase because it's a positive slope. If it was negative, we would say decrease,
Mhm.
and we would always just write the number without a sign on it. So expected to increase by 1.252 centimeters. Done. And let me get this away from that slope right up. So note that I copied this directly from here, which is also, right here on your provided reference sheets. If you don't like how this looks, write it on your reference sheet in a way that you like how it looks. So if I go back to our paper here, I'll show you the parts that we actually had to fill in. We had to fill in this. We had to put in that unit. We had to type in that word. We had to state it was an increase because it was a positive number. And we had to state the unit, the number of increase based on the slope and the units on it. All the rest we can always say. On average, always going to say that, comma, if blah, blah, blah. Why turn that up? So this part of the thing never changes.
The only thing that could change is if the slope was negative, remember, that it could be a decrease.
Right there, yep, that would be a decrease. We always think about the X as increasing, and the reason we do that is because we read a graph left to right. So we always think about going this way. We increase 1 unit of X, what's going to happen to the Y? Is it going to go up or is it going to go down? Good. Any questions on that? Okay, 10 says explain why the y-intercept of the regression line. Oh, look at that. Now we called it the regression line instead of the least squares regression equation. Does not make sense in the context of this situation. Before we do that, let's identify what the y-intercept is. And this is a mistake students often make. It's always an ordered pair. X is always 0. Y is always whatever the B value is in our equation. In this case, it's the 135,306. So this is the y-intercept. I'm going to interpret it. This is not what you need to write for your answer, but you need to know how to interpret these things. So we might as well just do it, right? The interpretation goes like this. No, doesn't do that. When X is 0, and so what is X? When arm length is 0 centimeters, comma, Y is expected to be 135.306 centimeters. Now, why doesn't that make any sense?
a really long arm for being not tall at all.
Right.
Really tall for not having any arm length.
Yes. Now,
They're a tree.
I mean, you can be born without a forearm, right? There are people that don't have forearms because of accidents or births or whatever. But what we're claiming is with a zero, that we could predict the height of someone with a 0 arm length, which is nonsensical because you're not going to have that, right? By and large. This is one of the cases where it could happen, but you can't predict something with a 0 arm length. You're not, I don't know. This one's a weird one.
How did you say you got the equation box again? Because I find it helpful.
Oh, I hit Alt equal.
Thank you.
And then you can do all kinds of stuff up here. Like there's you're getting me excited here. Here's mu. And here's sigma. And here's beta that we don't use. But anyways, there's like everything you could ever want to write is up there. So, okay, so the answer here is it is highly unlikely someone would have an arm length of 0. Number 11 says, what value did you give as your forearm length in centimeters? You know, just measure your arm. Oh, I don't know, 5 centimeters. Make up a number if you want. It doesn't matter. 5 centimeters is probably going to be too short. And then here it says, use the regression equation. Oh, here's a new word for it. Because up here it was regression line. Now it's regression equation to find the predicted height. Now, anytime we're predicting something, you are using the model, the equation. That's the predictor. So take your number and plug it in. Now, the question is, what is forearm length? Is that an X value or a Y value?
That's the X value.
Nailed it. So whatever number you put here is going to go right into your equation. What was that? Y equals 1.252 times whatever your number is, because we're replacing X with that number, plus 135.306. And that, just type in a calculator, it spits out your answer. And that's the work, by the way, what I've typed there.
So you guys will remember last night when we did this, we had a value where we plugged it in for Y and we had to solve for X. We had to do a little bit more algebra than what this one was.
I'm confused.
Talk to me. Which
What?
part?
Okay, first I could back up on 11. What does that mean? What value did you give as your forearm length and centimeter? Where are they talking about? What?
Well, remember how you took that survey where you had measured your height and your forearm? Yeah, you didn't. Sorry, that's the problem. Because I didn't give you the survey. So how long is your forearm?
I don't.
20 centimeters. Awesome. Thank you.
Oh, wait
Thank
a
you,
minute.
Becky.
Hang on, I
So-
have.
You can measure it if you want. Okay, all right. Measure it up. Let's see. What do you got?
I don't know. Let me see. How
You
do,
don't have.
it is. It says it's about 12 inches.
Oh, it's got to be centimeters.
Oh, well, shit. Shoot.
Hey Siri, how many centimeters is 12 inches? 30.48. I was a little bit off. Okay, there's your measurement. This is now your X value, and if everyone else wants to use it, great. Unless that makes you upset, Becky, then.
No, I don't know.
Okay, so Becky's cool if you all use it. So that's your X value, and that's the number that goes here.
Okay,
Now smash that in a calculator and you've got your answer.
and you did.
Very
all-
interesting information, Alexa. I did not
Hey,
know that.
Alexa, let's try it out. Oh, yeah, looks like it. I mean, from the big toe to the heel. I don't know about the small toe. I've heard about that one. Yeah, isn't like your wingspan
Arm,
something
it's the
too?
same. What? If you put your foot on your arm, it's the same?
Yeah, try it out. Show us. Let's do it. Don't you don't have to do that.
I don't know.
Let's get that. See how flexible everyone is.
Big toe to heel. Okay, maybe I didn't measure my forearm right, because I don't think so. But
Don't
Okay, so-
worry. It doesn't matter. Just make up a number. It's cool. The goal here is to make sure you get where do you put these numbers and how do you use it in the model to make predictions. So this is predicting a Y value for your height. And then here it says calculate the difference between your actual height and the predicted height. That's the residual. So that's this, let me see, where's the hat thing? That's operators, is it here? Oh, accents, it's here. Here it is. So that's this Y hat, and Y hat is the number you're predicting using the model. So that's why we like to label this as Y hat. No, come off that. Copy. Paste. There we go. Big toe to heel. Got it. I'm not flexible enough to like get my foot like. Oh, maybe I am. Yeah, you're pretty right. So you have to know your height in centimeters. And again, whatever, just make up a height. I'm 5'10". Hey Siri, how many centimeters is 5 feet 10 inches?
Yeah, how do you get the hat? Do it again. Show me how.
Yeah, I got the hat from the accent thing.
Okay, but what do you?
And I went to the one to the furthest to the right. This little box here.
And what is it? But how do you get to the equation?
Oh, this.
I mean, how do you
Oh, alt equal.
alt equal?
Yeah, there we go. Yep, alt equal. Oh, well, there you go. My hat. I'm sure there's other ways. I think there's like shortcuts programmed to hit to make it Y hat, but. How are we doing, y'all? Is anyone sitting out there just totally lost and has no idea what's going on and would love to ask a question, but I keep talking and putting my foot on screens?
Shit.
And it's being recorded. And it's going to be posted on YouTube. maybe
Can we just
I'll
play
develop.
with the equation tool and forget the other stuff?
Yeah, seriously. Yeah.
That'd be fun. Okay, so if we use Becky's forearm measurement, we get 143.467 centimeters running this. Then down here, we would put in that 173.476. If we use my height, Siri said that being 5 foot 10 inches tall. Oh, hey, how many centimeters is 5 feet 10 inches? She told me it was 177.8. So that's my actual height. If I had a 30.48 centimeter forearm, I would have been predicted to be this tall. So then we calculate the difference between those numbers, and that's called the residual. And that's something you all haven't learned about yet. I get 4.333. Yeah, Chloe, it's definitely because of your MacBook. I don't know what the equivalent in Mac of Alt is. Well, I could Google it real fast. Are you using Word or are you using Pages?
I'm using Word or Pages, I guess, actually, because it's on the Mac.
So you're going to hit. Oh, you use LaTeX, which is pretty
Where
hard.
even is that?
Shortcut key. Here we go. It is. Okay, so this says go to insert an equation or equations, and something should show up.
Okay, I think.
Oh, use the option key. So do Alt or option key equal, and that might make it happen.
It still put the little like dash through the equal sign, even if I put it on that insert equation.
Well, just buy a PC. It's cool.
Okay, yeah, I just put a Y with the little hat next to it.
You don't even have to put the Y hat in there. It's totally okay. I'm doing this on screen so to help you see the stuff from the textbook. You don't need to do it.
Okay, I figured you'd probably know what I mean by
Yeah,
that.
don't swear. Yes, that
you.
works too. You could even just do like Y hat.
Okay, thank you.
And don't go buy a PC. It's totally cool. So 14, we've stated what this is, right? We said this is the residual. Now I'm going to let you all do this prediction. For 15. So 15 is the same question as 12, except it's like what Cindy said, you got to do a little more work on this one because we've given you a Y value and you're predicting an X value. So you're replacing the Y. Oh, here I'm just gonna stop here and let you do it. How we doing? Does anyone know where the 12.7 should go in the equation in 15?
X, right?
Is this height or forearm length? Using the regression equation to predict the height of some, oh, I am so wrong. With a forearm length, yep, Becky, you nailed it, of 12.7 centimeters. Okay, this was boring. I thought it was the exciting one. Awesome. Did you get any? What did you all get?
150.960. Is that right?
I got 151.2064. Did I do something wrong?
Did I do something wrong? 1 sec. Oh, I did it again. I keep missing the 3 and,
Oh.
okay. 3,
No
the
worries.
1, yeah. Okay. So 1, 2.
Okay. It says, explain why the value found in 15 is not reasonable in the context of the situation. What is how much is 5 centimeters? Or 5 inches? Does it seem reasonable for someone to have a forearm that is this long? Man, I think even a newborn has a forearm longer than that. I could be wrong. That's pretty small. So that's the idea. A 5-inch forearm. Wait, is this centimeters? Oh, I'm sorry. Here's 5 inches. That was centimeters. So 12.7 inch. I guess that's sort of reasonable, but that still seems really, really. That's like half my forearm. So I think that's what we're getting at here is that 12.7 centimeters seems like a really small forearm. Which means it's outside the scope of the model. And we can check that by going back to our data set and seeing, what is the minimum in here in the forearm length? So I'm going to go back to our chapter 3 and I'm going to do summary stats, columns. I'm going to pick my X. And I just want to know what's the minimum and maximum in our data set. And yes, the smallest forearm that someone reported was 17 centimeters. And we just plugged in a 12.7 centimeter length, which is below any of the known data values, which makes it not a very good prediction. We doing okay?
I don't know about other people, but like when you do it and read it, it makes sense. But if I were to sit here and just read it and try to figure it out, that's the hard part.
That's why you're practicing. That's
Yeah.
why we give you my stat lab. Because the only reason it makes sense is because I've done this 1,000 times.
I know.
So no, it's good. That's exactly what everyone ever tells me. They're like, oh man, it's when you do it, it strokes my ego a little because it means at least I'm like saying things clearly. But also what makes it easy for me is that I have all this other knowledge that I'm just directly throwing in there. I've been in your shoes. I took some grad level classes where like, it was just like, I had no hope of ever understanding what was going on. And the best advice I got was you just write out all the definitions and all the things you know, and you start picking which things apply to what you're working on. And then you start to see the connections. I mean,
What
who
do we
has-
get for 13?
Say again?
13, what do we get for 13?
So it depends on what you put in for your height. I put in my own height, 5'10". I think that's how tall I am. And I compared that to using Becky's forearm, 30.48. So everyone could have different numbers for their 12s and 13s, depending upon whether or not you actually measured your forearm length or not. Does that help? Is that?
Calculate the difference between your actual height and the height predicted by the record.
It might help if I said that this was the predicted height. The model is a prediction.
Oh, we just got that from number 12, the 173.
That's right. Yep. And we got the 173 from our measurement of our forearm.
Okay.
Number 9. Here we go. Another thing that makes this maybe difficult right now is this is all of chapter 4. This encompasses all the knowledge of chapter 4. You've seen pieces of this, or you've seen about half of this. So you know how to find the equation from what you've seen in the notes. I believe you went over how to interpret the slope, how to interpret the y-intercept. You know how to take a value and plug it in and predict it. At least that's what you've seen from the notes. You haven't worked on residual yet. You've done this. You probably haven't talked about scope of the model yet. So that's the whole project. So that's part of what makes this a little wonky. So let's go, well, before I get crazy and move on, is there anything anyone needs to see or any questions on this that you all have?
Just on question 15. Should that be 206 because of the 3 decimals?
Yes.
Okay.
Thank you.
Can you go up a little bit just so I can see number 13 again? Because I'm still confused on.
Are you wondering where this number came from?
Yes.
I made that up. That's how tall, that's quotes how tall I am. So it's my actual height. So if you know your actual height, toss it in there. If you want to use my height, toss it in there. That's the other tricky part about this.
Okay.
Other questions? Okay, so let's go to the same thing, but a little less stuff. So let's go to the 4.2 worksheet number 4. And let's see how you do with this. Can you get through this whole worksheet? So let's do 5 minutes for the first page because it's, well, maybe we'll do we'll do 5 minutes and I'll check in. Set a timer for 5 minutes. Oh, it's page 532. Most definitely, you turn in that project. If you got it done, you want it off your plate and put it on mine, do it.
Are we doing just page 1? Anybody?
I'd say if you
Yes.
can go further, go further. Cause he's gonna have you go further. So if you're done. Eric, they wondered if they should go further.
Can we talk about it? Yeah, keep going. We're gonna
Talk about it.
Let's talk about it.
Use the left 2 lanes to take exit 1 beyond the left onto US 23.
West 23, nice. Hey, look at this. Least squares regression equation, correlation coefficient. Did everyone see them?
Yeah.
Okay, so what are each of these points represent?
Countries. Right?
Good.
Yes.
Can you be more specific?
Countries in 2007 or 2017.
Can you be more specific?
Countries,
All countries of the world?
world.
Good, good. That's, yes, this is all of the countries in the world. How do we know that? Because it told us. What does it mean to be all countries in the world? What is that special thing?
That means it's
Population.
population.
Good.
Like-
We don't actually need that. Doesn't do anything for us, but whatever. Now, why I keep saying, can you be more specific? Is because each point is a particular country, but it's also the contraceptive prevalence rate of the percentage of married women of childbearing age using contraceptives and related to the fertility rate being births per woman. So it's that information for each country. Now, I think probably what Alana's looking for here is just that it's a country, but it's that those two variables collected from the country and graphed in that manner. By the way, just in case you've forgotten, that's a great question, Misty. It is 5:32. If you haven't remembered, I sometimes take this for granted and I shouldn't. X is the horizontal axis, Y is the vertical axis. So each point is a country, and it's literally, what do we, let's do CPR, contraceptive rate. It's such a, isn't this such a weird thing that they've measured? It's just,
I said fertility rate.
fertility rate is the Y value. So it's both of these things. For a specific
Okay.
country.
So I should have both of them on there.
Yes,
Okay.
maybe even all three. It's a country, and it's that country's the percent of married women who can have children that are using contraceptives and the fertility rate.
Okay. See, I said fertility rate births per woman. And then obviously I added all the countries in the world.
Nice, nice.
Okay.
Okay, what was your answer to B?
Moderate.
Moderate.
Moderate, positive.
Moderate, negative.
Moderate and negative.
because of this thing, right? Now, is
Right.
moderate correct? Probably, because moderate is the scale of negative 0.5 to negative 0.8, and negative 0.75 is right in the middle of that. It's actually closer to the 0.8, so good. Oh, it did matter that we identified it as a population. What's the answer to C?
Parameter.
Because
It's a
Population.
population.
the population, it's all the countries of the world. Okay, so someone asked this in the chat, was it Sarah? You said, would D be the interpretation of the slope? Yes, that is the script, exactly. But first we have to state what is the number for the slope.
Negative 0.05.
Nailed it. One of the, and
Just
I'm gonna
hold
put
that
it
up there.
over
the mirror.
one,
How did
just
we get that?
because.
Oh, you got it.
Can you, but why did we get that?
Talk to me, Becky. Where did that come from?
Oh, up top. Why?
You got it. You
Okay.
got it. Good. Some people put X with this and they're wrong. X is not a part of the slope. X is literally the contraceptive prevalence rate. Now, let's see, 0.05, what this is, that's the fertility rate, negative 0.05 per 1% of married women who are using contraceptives. So then you explain what it means in context. Anyone get that?
No, I'm lost on that one.
Everyone
On,
knows. Do you know where your script
on
is?
how to, on D, on exactly how to explain it.
Right
or-
here.
Are we doing the interpret? Yeah.
That's it. Use your script. That's your
Okay.
guide for how to interpret it.
Okay. There.
Average of.
Oh boy, what page are we on? 532.
Wouldn't it be decreases by 1%?
So X always increases.
Okay.
But you're right, the Y, because it's negative, the fertility rate is expected to decrease by 0.05. Oops, not percent. Births per woman. Can I make that larger? Maybe not. So notice again that the parts that we added are this, 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 and this.
Oh, Jesus.
So, question.
Yeah.
So, even though the fertility rate is negative 0.05, you wrote a positive 0.05.
Look at the word before it.
Because when we write the script, we don't put the negative in front of the number because the word in front of it depicts.
Already
what it
says that.
actually
Yes,
means.
you're right. Okay, thank you.
We don't write the positive in front of it, the plus sign in front of it either, but we don't really think about that because
That's just be one of those things I'm gonna probably ask again.
No, it's totally fine if you do that. And if you say is expected to decrease by negative 0.05, I'm not going to mark you wrong.
Did I tell you guys? I said that. I said Eric probably will not mark that wrong if you make that mistake.
I wouldn't. It's a double negative, right? So a
Yeah.
negative times a negative is a positive, but I mean, you know what you're doing. I don't think I've ever marked that wrong. I've seen it happen. It's not too common, but this one, lots of folks get wrong. What did you write for the y-intercept?
It would be 5.30.
Really close. You're half right. What's the x value? This is me being picky. But you need to include the x
So that
value.
value would be 0.
Yes, every single time. You're always going to have 0 comma some sort of number, whatever this is. And that's because we're saying when the x value is 0, we expect the y value to be this. Nice, Shelby. Crushed it. How about I sit quiet for another 5 minutes so you all can do this without me. Set a timer for 5 minutes.
Do we need to put the script for E2 for the y-intercept?
Yes.
Because it says explain?
Yes. This one's possible, right? You could have no one using contraceptive in a country. Maybe.
So how would I explain this one? I don't understand how to explain this then.
I am so with you. It's right here. Let me change the color.
Yeah, but
Shh.
so what's X?
Oh, great question.
Is it CPR, the contraceptive?
Here's X. And if you want, you can copy and paste that whole mess. Here's Y. And you copy and paste those words exactly. That's the definition of the variable. That's what those two variables are. And if you want to shorthand it and do CPR and FR, that's fine too. Does that help?
Yeah.
Good, good. It's definitely strange when you first get it, and it's usually the most hated part of this chapter.
So do I say for E, on average, if the CPR increases by 1%, fertility rate is expected to decrease by the 0.05
For
Right.
D, yes.
for D, yes.
So for
Okay.
D, we're interpreting slope. For E, you're interpreting the y-intercept.
Okay, so,
So note here it says slope interpretation for this first one. That's the on average if blank increases, blah, blah, blah.
oh,
And then here,
oops.
no worries, you're good. Here we're doing the y-intercept interpretation. And so one of the things that to keep track here is slope is a rate of change, blank units per another, whereas y-intercept is a fixed point. It's one data value on the scatter plot.
Okay,
So here, let's write it. When X, so when the fertility rate, wrong again, when the CPR, the contraceptive prevalency rate is 0%. So there is not a single married woman of childbearing age that is using contraceptives. The fertility rate of a particular country, so we're going to say FR, the fertility rate is expected to be 5.3 births per woman. And often the question that goes with the y-intercept is whether or not that value makes any sense. And there's two pieces of the y-intercept that may or may not make sense. It could be that having 0 of a particular variable is nonsensical. Forearm length of 0 typically doesn't make a lot of sense unless you don't have an arm, right? Other examples of this would be like literacy rate of a country being 0. That's really difficult, I think, to have that happen. Usually if there's any form of government, there's going to be some form of reading and writing that someone has to know. So in this case, I guess the question is, if we want to think if this makes sense, is it possible for there to be no women on birth control in a particular country? I know there are particular groups in this country that don't want to be forced to provide healthcare that provides birth control, right? So it's, to me, that seems like it's entirely possible that there could be places where birth control, people don't have access to birth control. Anyways, that's the kind of thought process you go through, and you're looking at the two things. The other one that could happen is if the y variable is a negative number, that often doesn't make any sense unless it's money. Then you can have negative money. But sometimes the 0 is reasonable. You could have nothing of a particular variable, but then you have negative of the other one, and that one's not reasonable. So you're looking at either of those two things, and if one of them doesn't make sense, then the entire y-intercept doesn't make any sense. And that's common because the 0 as an X value is often outside the scope of the data set. How'd you all do with F?
I'm just completely lost on this.
Yeah,
yeah, so am I.
I didn't do anything with it.
Okay, awesome. Let's read it. Canada had a fertility rate. Pause. What is fertility rate as our variable? Which one?
X.
Y.
Oh, Y, yes, right, yes, Y.
Okay, good. It's Y. So let's label that in our minds as this is the Y variable. In 2017, oh, it says of 1.5 births per woman. So we know that we're just being told that the data value for Canada is 1.5 for their birth rate. Okay, so then we get the question, what does the linear regression model predict? This is saying, take that equation, this one right here, and figure out what does it predict the prevalency rate for contraceptive use in Canada, whatever that is trying to say, those words.
Yeah.
So pause. What is this variable? Prevalency rate for contraceptive use? X or Y? X. Okay. So that means we are going to do some sort of calculation that gives us the answer to that question. So take the regression model, y hat equals negative 0.05x plus 5.3. Replace the letter we know, that happens to be the y value, with what we're told it's equal to, 1.5, and find x. How much do y'all love algebra?
So I don't, and I'm still very confused.
Oh, talk to me. Which part?
Oh, this is where Cindy said you, like, so to
We're
get
trying
rid
to
of,
find X.
yeah.
Yes,
So we're
so
gonna take-
basically, okay, so.
So do we gotta get rid of the 5.3?
To get the 5.3, because it's added, you have to subtract it to both sides to cancel it out. So you would subtract the y value by 5.3.
Okay, so let's do
So
that.
then you would be left
Yes.
with negative 3.8, which equals negative 0.05x. So then you have to divide, because the 0.05 by x is a multiplication problem. So to get that by itself, you have to divide the 0.5 from the opposite side. And that will give you your x value.
Okay, so 1.5.
So you took the 5.30 from both sides first, correct?
Right.
Yep, I subtracted it from both sides first.
Okay.
Do you all want to see a trick so you don't have to do any of that?
With Desmos.
Yes. Are you ready? So here's a way to get around it. This is a legitimate algebra solving method. It's called solving graphically. It does require one thing that you think about. Now, if you love the algebra part, go with it. Sarah, it sounds like you got that. So run wild with that. What you should note is when you have an equal sign, there's two sides, right? There's the 1.5 on one side. There's a negative 0.05x plus 5.3 on the other. So we could just say, all right, let's let y equal 1.5. That's one side. The other side is y equals negative 0.05x plus 5.3. How's everyone with that?
Yeah.
Then all we have to do, the answer to this equation, the answer for x, is where these two graphs intersect. Can you tell that they're going to cross somewhere over here? Oh, hey,
Yeah.
there it is. Do you like that?
So that's X, correct?
So the x
No.
coordinate of this ordered pair, yes, is the
Okay.
answer. Now, if you like that, by all means do that. If you don't like that, let me write down the algebra, which is what you would have gotten in the notes, and it's a totally valid, another valid way to solve it. Oops, but let me clean this up because you need a little bit of space. So what we have here is we had that 1.5 was equal to negative 0.05 times x plus 5.3. How I taught this in my algebra classes is I said, look, we want this by itself. So we have to first get rid of this piece. And the inverse of adding, what would make this 0 is subtracting. This is what Sarah was saying. Here we get negative 3.8 equals negative 0.05x. Okay, we've got that piece by itself that we needed. Now we need to get rid of this piece so we have 1x. Well, if we're multiplying, the thing that gets us to a 1x is dividing by the same thing we're multiplying by. So I'm going to divide by negative 0.05, both sides of the equation. These go away. And we're left with x equals whatever this division is. And your calculator will tell you 76. It turns out in this class, this is exactly what you're going to do every single time. In fact, I can give you a formula for x. It looks like this. X equals y minus b divided by m. You could use that formula to solve for x every single time. Just plug in the numbers. The only tricky part is if your b value is negative, you got to recognize you're subtracting a negative number. Okay, how hateful is that?
Okay, so do we just use the formula as the answer, or do you want an explanation too?
I could care less how you got there. You could
Okay,
use Desmos and graph it, or do the graphical method like I showed here to get there. You could do the, what do we call this? The analytical method, where you show the work to get there. Or you could write down this formula and use the formula method, just like you do for the z-score or otherwise.
Okay.
So there's 3 ways to get there. You do the one that you're most comfortable with. Or maybe I should make you explain all 3 ways.
No,
No,
No.
yeah, no.
I don't understand. I'm confused by all
I
of
would
them.
really like to see the Desmos thing again.
Sure. So let's see. So the Desmos thing requires you to write an equation for each side of the thing you're trying to solve. So if you look at what you have here, we've got one side of the equal sign is just the number 1.5. So I type that in here as y equals 1.5. You don't actually have to put the y equals in there even. You can just type both sides of the equation. Maybe I should have done that. No, you do have to put the y equals for the 1.5. I'm sorry, otherwise I won't graph it. So maybe it's a good idea to just keep that in mind. So you've got the one side, which is 1.5, and then the other side of the equation is this negative this. And so what you do in Desmos is you
That's
take
the hound's brother.
nice. You
I
take
think.
this, you're good. This side and write that as one equation. And take this side and write it as another equation. And then the solution is where they intersect. Now, the tricky part with this is finding where they cross. If these if these numbers are really big, it can be a little tricky trying to find them, but you just zoom out and you see that Desmos puts in these spots, these little dots, and you're finding the one where they're crossing each other.
Okay.
Then you don't have to do any of the algebra stuff.
Love it.
Yeah, I do too. When I taught pre-calc, this is like, I'm like, everyone, why not just solve this way? We got the technology to do it. And there's some equations that we don't have an analytical way to solve them in pre-calc. Here, it's all we do is this one linear one. Works every time.
I'm gonna put that in my favorite bar.
Yay. Oh, yeah. Okay, how is G different than F?
F is a prediction and G is an actual.
Well, except though it does say, what would the model predict?
It's given us the Y value instead of the X.
No,
Let's
it's
see.
giving us the X value instead of the Y.
Oh, yes, yes, yes. Yes.
Right? So they're saying, hey, the contraceptive prevalence rate is 63%. Oh, we know that that is an X variable by looking back at the graph. The other thing is to look at the units on the numbers. This is a 63%. X was in percentages. So we know X, and it says, what's the model going to predict? Well, write down your model. Y hat equals negative 0.05X plus 5.3. We know this to be an X value, so erase the X and put in there the value for X. And this one, we don't need any fancy stuff. You just type it in the calculator, right? It's just that 0.05 times 63 plus 5.3.
Y hat equals.
And this is, I did something wrong because that number is insane.
Yeah, how is it 153 and I got 2.15?
Because of how I typed it in my calculator. You know what that's saying? That's saying that there's 153 births per woman.
Shit.
Yeah, right? Even I know that's the correct response. Okay, 2.15. That feels a lot better.
How did okay, then I'm doing something wrong. I keep
Did I still
getting,
get it wrong? Am I still getting it wrong?
no, I keep
That's what
getting
I got.
8.45. What am I doing wrong?
I got 2.15.
So I'm multiplying 0.05 by 63 or 63 by 0.05, right?
Did you do
Yes.
negative?
Are you
Negative.
putting the
Do the
negative in,
negative.
Betsy?
Ah,
Yeah, yes. That's what kept me from good grades in high school too, the old negatives.
$2.15.
Got it. Nice. Okay, so then we're told Kenya actually had a 3.5 births per woman. So this is a Y hat value. The reason we put the hat on there is so you recognize it was a predicted value using a model that we drew from all of the data values, that linear correlation thing we did. So Kenya here, we're told it's actually 3.5. We're calling this Y as in it's an actual data value. And then when you talk about this on whatever you talk about it, you'll learn that it's Y hat minus Y. The predicted value or the estimated value minus the actual value. And that's the residual. Now, if you think about what this is saying, this is saying that when our model predicts relative to all of the other countries that if 63% of married women are using contraceptives, then we expect about a 2.15 birth rate. But actually, Kenya has a higher birth rate than that. So our model underestimated the value because it's a negative residual. That could mean maybe contraceptives in Kenya are not particularly effective because they have a higher birth rate than is expected relative to the model. It could be just the model's not that great. There's bunches of things that could happen, but what that means down here is the reality is that Kenyan women are having more births than what we expected. And we know that because it's a negative residual. because the predicted value is smaller than the actual value. So when you get negative residuals, we call that an underestimate. If you get a positive residual, we call that an overestimate. And depending on the context, over and under could be negative or positive connotations. Like, I don't know, if Kenya is trying to grow their population, then this is great. You want higher than 2. A birth rate of 2 means your population is stagnant. A birth rate less than 2, like this Canadian birth rate, that means that Canada will cease to exist in the distant future, because there's only 1 child to replace the 2 they got together to make a child. We definitely need more practice of this, right?
Oh,
Yeah.
yeah.
Yes.
100%.
I'm so glad you asked for that. We're also out of time, but what we're going to do, I think, on Monday is we're going to look at this chapter 4 review. And this is more practice of all of this. And the questions are very, very similar. Is there more on this worksheet? I think there's one more page, isn't it?
There is.
We can
Yeah,
also
there's one more
finish this page. Yes. So this is the same thing. It's just now you have to generate the data like we did in the project. So you need to stat crunch this stuff. So we still have the 4.1 worksheet that we can work on for practice. This is the 4.2 worksheet. There's other ones we can do for practice. And then we have the 4.3 worksheet plus the chapter 4 review. And there might be another project. I know there isn't another project. So we do have lots more practice. I think in terms of due dates for any of these, they don't need to be turned in on Sunday. We can push the due dates for all the chapter 4 material to next Sunday.
I love that.
To give you more time. I just need to remember to change it in the computer.
Yeah, this is really confusing.
It's
Yeah.
yes, this is a lot of new stuff and there's a lot going on here. And it's totally different than the previous chapter.
I was feeling really good, confident about this, and then this totally deflated my confidence.
Yeah. That's how I feel.
Give yourselves a little bit of grace in that you didn't see notes over some of this yet, right? So we just did practice problems of things that you haven't seen in the notes because you haven't made it through all of 4.2 or 4.3 yet. So judge your understanding of it after you've seen the notes tomorrow.
Okay.
You guys got this.
You do.
We'll get you all fixed up tomorrow.
That's right.
Okay.
So I'm happy to
Promise.
hang out a little bit. Cindy's driving. Cindy, you get out of here. Go enjoy your family and thanks for being here.
Hey, it's dark.
Nice.
I'm still here.
Yes, see you all. This is how much Cindy cares about you.
Yes, she does. Yeah. You
Yeah.
both-
This is why you all are going to make it. You got the best instructor out there here
Both,
helping you
yeah.
get through.
Oh, yeah.
Well, I don't know about me, but when I finally grade things, maybe we can feel better about me.
That's true. Let me take that back. Let me wait till I
Yeah,
get back.
take that back. You know what often happens to me is when I get super far behind and we've done all the problems in class, lots of 100% pop up. But I'm not going to promise that. So if anyone's watching the videos and think that they should just turn something in, don't do that. But seriously, that's it for tonight. I'll hang out as long as y'all need to answer questions. LaShawn, did I have it backwards? Observed minus predicted. Let's go back to the residual formula. You're probably right. Oh, cool. Well, this is why Cindy's gonna fix you up tomorrow night, because I just did it wrong. It's supposed to
Night,
be
Misty.
y minus y hat, not y hat minus y.
That's exactly where we're starting tomorrow. So we'll get it fixed.
Oh, so,
Misty.
yeah. You just scream at me when I do that. Yeah, I mean, so the thing is, it doesn't particularly matter which way you subtract it, but it does change what you treat a positive and negative residual. So yes, that's good. Positive residual would be an underestimate,
What,
and a negative residual would be an overestimate. So it switches how you say that.
so which question?
Does it change the, does it change the equation? Or the answer?
Yes. So when you subtract it this way, you're going to end up with a positive 1.35.
Okay.
Which means the project would be the same way, whatever. So you would do 3.5 minus 2.15, which equals a positive 1.35. So now what this means is the observed value, the actual data value, is larger than the predicted value. So we would now be calling, which I feel like this got switched, we would now be calling a positive residual an underestimate. Which makes sense because the thing is below that.
What I had written down is underestimate already.
Yeah, it's still the same thing. It's just now the number is positive, and so we associate positive residuals with the word underestimate.
Okay, so it'd be answer number 3. Kenyan women are having more births than expected due to a positive residual.
Yeah. Yeah.
Okay.
So yeah, you guys will go over that tomorrow night about like why that's called. It seems funny that a positive number would be an underestimate, but we'll explain that tomorrow. It's just because of what we predicted.
Other questions y'all got? That's a good, thank you. If you're still here, LaShawn, for correcting me. I
LaShawn,
need that.
yes.
Okay, so then just to clarify, on this list here, worksheet 4.1, number 2, and 4.2, number 4, not due until next Sunday, which is whatever date that is. I don't know what date that is.
2nd of October.
October 2nd.
October 2nd.
Is
I
that
actually know
correct?
that one. Yes, that's
Gosh,
correct.
October.
Okay, and
So
those are ones that we're supposed to be doing by ourselves, right? Out of class, or are we doing it together in class? I forget.
I think I need to spend some more time with you doing those. I think the one that you should try to do yourself is the chapter 4 review, but you're not really ready yet until you've done all the notes. So let's just say that there's nothing due on this Sunday other than that 3-4 worksheet, I think.
You guys, I still want you to guys, I think you guys are fine to try 4.1 worksheet 1.
There we go.
I think we've done enough with just putting it
Yeah.
into StatCrunch, and that was not, I think you guys were confident after 4.1. So the only worksheet that needs to be turned in this week is for me for 4.1 worksheet 1. And then as far as the My Stat Lab, I'm gonna keep the same due date because you could work past the due date. So that, remember, those are suggested due dates. So I'm gonna leave them. You can work past the due date. So if you want to get in there and mess around with 4.2 and 4.3, after tomorrow, hopefully I can make it make a little more sense after doing notes. You can work past the due date in my stat lab with no penalty.
Eric, can you show me the Desmos? Because I'm doing it on mine and I don't know what I'm doing wrong.
So I did y equals the data value and y equals the regression model. And then you had to scroll around to find it. Like if this is the picture you saw, you can't see it, so you can zoom out. And then you can hold your mouse and move it around until you see where they cross. And then if you just click it, there they are. So that's the tricky part of the graphical method, is finding where they cross.
Yeah, I'm still doing something wrong because mine are still like completely, they don't even cross.
You want to share your screen?
Sure.
So you're hit the home button on the far right, that little house. On the far right of the screen, you're on, I think you're on the left side, yeah. You go down from where your mouse is a little more. 3 more. Below the minus sign. Doom, hit that, there you go. Okay, so you were just zoomed way out. So hit the minus button like twice. 1, 2. And now put your mouse in the area on the graph and hold it and move it left. There you go.
See, I've been doing this and it's still
Oh, I know, I see it. Look at your equation, the blue line. You
okay.
have y equal, there's not an x in there. You need the x. That'll fix it.
Oh,
Bam. Now hit your home key again and you should be able to find it scrolling around a little.
there we go.
There it is.
Perfect. All right.
Now you still have a mistake in your equation. You have 0.5 instead of 0.05.
Oh,
That's why you have 7.6 instead of in the blue line, not there. The slope of your model is off.
this year? Oh,
Yes. So now you have to scroll like, yeah, there you go. You got it.
okay. It's still gonna
There
be
it
the
is.
same, but
Yeah.
And
Now
that's
it's-
just for the linear regression, right?
Yes, you can use this method to solve for X when you're given Y. If you didn't like all that algebra, subtracting 5.3 and dividing by negative 0.05 stuff.
I have to like take out time just to sit down and organize everything, like where everything needs to be, like even just this, understanding that and having it in front of me. Anyways.
Well, and here's the good news. When we get to chapter 5, it'll slow down a little bit.
That's what Cindy keeps telling us.
I do. I keep telling them.
It's more
It really
complicated
does.
material, but you're do one section a class period.
But my problem is at my age, if we're gonna do this one through 4, I want to understand 1 through 4. So I'm not feeling lost.
Right.
rest of
Yeah,
the way.
come
You know what I'm saying?
midterm.
Right, like I can study for midterm, but it's to understand the information because I don't want to feel lost when we get past 5.
Eric, we can always, because we have 3 days of review for the midterm.
Oh,
We
nice.
can, what we can do right now is like tomorrow. I don't need to get into chapter 5.
Oh, yeah.
I can just finish up spend more time on chapter 4
Definitely.
and not rush through it.
Because I'm with
I will-
Becky, because I felt pretty good 1 through
Yeah.
3.
So why don't I
Sure.
do that? Why don't we push everything back? Like I'll make a new schedule and push everything up a day. So we'll have 2 days of review instead. We don't need 3 days of review.
No. Well, this is my fault because I just went ahead on stuff you haven't covered yet.
And
So of
that's
course you're
okay.
not gonna
It gives
feel
us a
good.
snapshot, but now it'll be
Yeah,
good. when
yeah,
we do
yeah, no,
know.
I think it
Yeah.
was fine. But I
But that-
think
yeah.
because we have 3 days, I think chapter 4 is like
Yeah.
algebra and it's just a lot of words. But once we get into chapter 5, yeah, it's getting dark here. Anyways, why don't I do that? Why don't I tomorrow we'll just back everything up a day. And so tomorrow we'll spend more time and we'll get you guys really comfortable so that you feel comfortable with chapter 4 before I throw 5.1 in there as well.
Yeah, I would feel.
'Cause like I
Would
said, I
that-
don't know if you were on, Cindy, but earlier I was telling Eric, I'm like, when he does it, I'm like, oh yeah, it's logical.
I know. Yeah, well, absolutely. And
But when I look at it, I'm
obviously,
like,
and
waving the
obviously when I'm filling out notes, you're like, oh, I get this
That
too.
makes sense, yeah.
It's like when we set you free, it's like, oh no, what do I do now? So that's why, Eric's setting you free, but when we fill out notes, sometimes I'll ask you guys questions, but I'm the one that's giving you the information. And Eric says, okay, now let's practice it.
mhm.
So, yes, we will. So what we'll do tomorrow is I can actually maybe pull up a couple of these worksheets and we can work on a worksheet, maybe something that, but we'll get you guys comfortable with it.
I
So
think
that's
even-
what we'll do.
I think even some of us can chime in to say, okay, this specific problem is, I get this one, but I'm not getting this one.
Yeah, absolutely.
And some of the people who aren't talking might say, oh yeah, me too.
Yeah, we get it, you guys. If for those of you that are talking don't get it, we know the ones aren't talking for sure don't get it. We
Yeah.
know. Okay, that's the plan then. So
Cool.
tomorrow
Good.
we will spend time to go over and make sure you guys get chapter 4 before.
And I'm
we move
planning on
to-
Monday spending some more time too,
Okay.
chapter 4, if we need it.
Yep.
Hopefully we'll surprise you on Monday.
So then,
Yeah.
so on Eric, then on Wednesday, I'll lecture 5.1 on Tuesday then. So on
Okay.
Wednesday, you can plan on doing whatever you want for
Perfect.
5.1.
Hey, Eric, for project, chapter 3, project 3, can you reopen mine because I submitted the wrong one? And I want to submit the correct one.
Let's see, I don't know if I can. Yes, I think I can. Does it say unlimited? Yep, there we go. I thought I
Cool.
fixed all these.
Thank you.
Thank you, yes. Kayla, for page 3 on 4.2.
Bye, everybody.
See,
Hi,
Night,
Patty.
Patty. I'll see you tomorrow.
you got to enter this data into StatCrunch. This is essentially the project. You're doing this in StatCrunch and you're generating this from StatCrunch. So that simple linear regression stuff. And from there, the equation will be here based on how you label your var1 and var2. And then for there, you'll get the slope, just like we picked it out from here. Here's the slope. Here's the y coordinate, the y-intercept. In fact, this question 2, is the same question as this one. It's just, we handed you the stuff you needed to answer the questions. You have to find that stuff, that least square regression model in StatCrunch, and then find the slope and the y-intercept, say why it doesn't make sense. Here's another prediction problem, just like we did right here on F and G. So same thing there. And then here's a residual question that, don't do what I did and use the wrong equation. So do that. And then which one is it? So I think I'm going to let you all struggle with this one because it's extra practice of the exact same thing. Did that help at all, Kayla? Or did that just make it worse?
A little bit because I plugged in the stuff that was in the table into StatCrunch, and I'm just having a hard time trying to figure out, like, for 2B is saying what is the slope of the line of the regression line, and I put weak positive because I went over a little bit and I looked at the graph, and the graph kind of has
Well,
like a
Well,
slope.
what is slope? So that weak positive stuff is when you're talking about R. Slope is the number times X.
Okay,
Is that
a little bit. It makes sense a little bit.
so? If I were to show, so if we go back to the project one, this is what your thing would have looked like. Although if you didn't relabel it, it probably said var1. Oops, what's going on there? Variable 1, variable 2. Okay, let's just variable 2, and the number times variable 1, that's the number for your slope.
Oh, okay.
And then for the y-intercept, the number by itself, you would write just like how I wrote it down here. Wait for it. Here, this. Parentheses 0, comma, the number by itself, close the parentheses. There's your y-intercept. And then you're doing those same interpretations. Here's the slope interpretation. Here's the y-intercept interpretation.
Why do we have to combine English with math?
I know.
Would you rather it be
so
French?
confusing.
Or Spanish
much.
or German?
It's too much.
So it's a really, I think it's a really good practice problem to keep going because it can help identify, are you catching the language? It really is, right? We don't ask you, you're not asked about R anywhere on number 2. So you're not at all concerned about the strength, the relationship between the two variables. The time that you're
Okay.
reporting that is when it says, describe the correlation, or what's the relationship? Cool, good questions. What else y'all got?
I just have a question about the project,
Mhm.
because in the project we did the equation, the y hat minus y, but we did it backwards in there too. Do we need to go through and, like, because I've already submitted it, do I need to go through and change it?
No.
Okay.
I mean, if you're going to use that for study, maybe you should. But if you're just submitting it and are done and you're happy, don't worry about it. I'm not going to mark you
Okay.
off.
Okay.
This is what it was supposed to be, which just changes this to a negative. Other questions y'all got?
Yeah, I'm done.
Yes, it's been a lot of math time. Go relax. Take a nap. I guess it's bedtime. Right?
Well, I hope you guys have sweet dreams. I'm gonna have nightmares about X's and Y's.
Me too.
That doesn't
Y'all have
sound like a
good evening.
nightmare.
Thank you so much.
What happened?
That's a sweet dream to Eric. It's a nightmare for the rest of us.
Yeah.
All right, everybody have a good
Thank
night.
you.
Cindy,
You
you
have a
guys
good evening.
Good luck, y'all. Sleep good.
Good night, y'all. Have safe travel, Cindy.
Yeah.
Who's available to get together? Probably this weekend to do some study time to try to catch up a little bit.
What day?
Whenever I'm available, pretty much all the time. So it's whatever your guys' availability is, I can work with.
I'm available Tuesday, Jesus. Saturday or Sunday, so it doesn't.
Jen,
I
why
feel
don't you,
like-
Jen, why don't you send a text to those numbers that you wrote down last night?
Yeah,
And see if any of those would be able to do. I know that Nikki said that she would be able to do like Sunday evening. So
yeah, and I was talking to Laura earlier, so
yeah, and Nicole, I know Nicole said that she had like a Zoom link. I see Eric's doing that right now, but there was 2 or 3 of you that said that you had actual Zoom links that you could send out
Mhm.
to schedule a meeting.
okay.
So this, what I went to as well, this is Leah Post something, I don't know how to pronounce her name. She has availability on Saturday at these times for tutoring sessions.
Okay.
If you go to
Okay.
the student center, the place she's available, let's see.
Okay.
That's
So that's
actually
another
gonna,
thing, and you all could meet with these virtual tutors. Here's another person on Saturday and Sunday. Oh, they got tons of time.
There you go. That's great.
So you
Yeah,
could
yeah.
individually, you could meet as a group with this person. So that's, I don't know, do you all know how to get there? Do you need that link?
Yes, please. Oh, no, I know. Yeah, I know how to get there.
You know how to get there. Okay,
Yeah.
just another option, as well as your classmates. This is where it is.
they are
Um,
actually gonna do this as a forum, I think maybe next week.
Oh, nice.
Yeah.
Oh,
So, Jen,
Amina,
I-
I work with Amina. She's very good, by the way.
Jen, I sent you my number as well. So if you want to text us and
Yeah, definitely. Thank you.
I can send you my number too.
I think the more of us that get together and we feed off each other, thoughts and ideas and.
Right, right.
It's the only way I made it through grad school.
Mhm.
I got with the person that looked like they knew what they were doing and fed off of
I was
them.
just gonna ask you, Eric, if you knew of any of those tutors, but you just said you did.
I know Amina, she was my SI. I know she's very good. I don't know any of the other 3, but I'm sure they're good.
I'm sure they're good. Yeah.
They usually get good tutors.
and Jen, because you need help with some stuff that we've already done, right?
Yeah, yeah. It just because of medical stuff last week, so.
Okay. So that's the stuff we feel more confident about.
Right.
so-
Yeah.
Once it's on chapter 4, you're good.
Yeah.
Okay, yeah, just send us a text.
Okay.
All right.
All right.
All right. Thank
right.
you.
You're
Well,
welcome.
I'll see you guys tomorrow night then.
Okay, drive safe.
Okay.
All right. See
All
you
right.
tomorrow night. Drive safe.
Thanks, Jen. Bye-bye.
Bye-bye.
So Eric,
Go ahead.
yeah,
Oh, stop recording. I gotta remember that.